Welcome back, grade 11. Let's continue talking about modern periodic table, okay? Scientists arranged elements in modern periodic table to facilitate their studying and find the relationship between the elements and their properties. The total number of elements found in nature, 118 elements, 92 available in Earth crust, while the rest artificially prepared, okay? In modern periodic table, the elements are arranged according to 2 points. Number 1, according to atomic number, okay? The element arranged in ascending order, okay? According to the atomic number of the element, and also arranged according to the way of filling energy sublevels with electron. We know that the energy sublevels found in atom, we have 4 energy sublevels, okay? S, P, D, F, okay? And by looking to the table, we notice that the table composed of 7 horizontal periods and 18 vertical groups. And the table composed of 4 blocks. Look to the 4 blocks of the table. We have S block element, okay? This is area known as S block element. This is area known as P block element, okay? And this is area D block element, and this is area known as F block element, okay? So we arranged the element in modern periodic table according to, or in ascending order according to atomic number and way of filling energy sublevels with electron, okay? So by know the atomic number of the element, we can determine its location inside the table, where the number of the period refer to the number of energy levels occupied by electrons in element atom, and the number of group refer to the number of electrons that found in outermost shell. For example, if we have a calcium atom, okay, and by knowing the electronic distribution inside calcium atom, we found that, okay, the calcium composed of 4 periods, okay? So the number of period it located in period 4, and the outermost electron it contain, or the outermost shell, it contain 2 electrons. So the calcium located in group 2A. Today we will talk about the blocks in table, okay? Look to this is diagram in the front of you. We have the first block known as S block element, okay? It located at the left side of the table, and it composed of 2 groups, group 1A and group 2A. Group 1A known as alkali metal, while group 2A alkali earth metal, okay? So the location of S block element located at the left of the table, composed of 2 groups, group 1A and group 2A. Group 1A, the name of the group 1A known as alkali metal, okay, and group 2A known as alkali earth metal. After S block, we have another block, okay, P block element, located at the right side of the table, and it composed of 6 groups. It started from group 13 and end at group 18. The most important groups in this block, group 17, which known as halogens, okay, the strongest non-metal in table, and group 18 known as noble gases, okay. D block element. D block element, the location of this element, located in the middle of the table. This is element start appearing from period 4, okay, and it include the transition element, okay, the main transition element, okay. So the name of the block element, the transition element. The name of the metal locate, the element located in S block element, representative element. The name of the element that found in B block element, known as also representative element, okay. Also, F block element located below the table, okay, includes lanthanides and actinides. Lanthanides, okay, equal 4F, and actinides equal 5F, okay, and they known as inner transition element. So again, periodic tables consist of 4 blocks: S block element, P block element, D block element, and F block element, okay. You should to know the location of each block, okay, the name of each block, okay, and also the most important groups in each block, okay. From the most important properties in table, atomic radius, okay, electron negativity, electron affinity, ionization energy, and also we will talk about metallic and non-metallic properties in table. Let's start with atomic radius. Okay, what's meant by atomic radius? Atomic radius defined as the distance between the nucleus, atom nucleus, and the outermost orbital of electrons. And we calculate the atomic radius by another way. It's the distance between two nuclei of two identical atoms that are bonded together. Okay, and the measuring unit used to measure atomic radius, picometer. Okay, which equal part of million part of meter. Okay, so again we calculate the atomic radius by calculation the total distance of the atom's nucleus to the outermost orbital of the electron. And if the two atoms bonded together to make diatomic molecule like hydrogen and oxygen, we can calculate the atomic radius by calculating the distance between two nuclei of two identical atoms that are bounded together. The measuring unit used to measure atomic radius known as picometer unit. By studying the atomic radius in table, we find that, okay, in periods, when we go from left to right by increasing the atomic number, the atomic radius decrease, okay, due to the more attraction force between positive protons and the negative electrons leads to decreasing in atomic radius, okay, and in groups, when we go from up to down, okay, by increasing atomic number, what happened? The atomic radius increase due to the increasing of number of energy levels. And according to this information, we find that cesium atom has the largest atomic size in table, and the cesium atom located in group 1A, while fluorine atom in group 17, okay, has the smallest atomic size or smallest atomic radius. Okay, fluorine atom located in group 17. Okay. The second property, electronegativity. Electronegativity means the ability of an atom to attract electron in covalent bond toward itself. Okay. In periods from left to right, by increasing atomic number, the electronegativity increase. Okay. And in groups from up to down, by increasing atomic number, the electronegativity decrease. Okay, and according to this information, fluorine has the most electronegativity and francium has the least electronegativity. Okay, the difference in electronegativity between atoms, between elements of atoms, determine the type of the bond they will form. Okay, if we have the difference in electronegativity between atoms high, greater than 2, okay, so the bond that is formed is known as ionic bond, like the difference between sodium atom and chlorine. Okay, by calculation, the difference between electronegativity of sodium atom and the chlorine atom, we find that, okay, we have 2.1. So the ratio or the difference greater than 2. So the bond that formed between sodium and chlorine is ionic bond. While when the difference of electronegativity between two atoms is low, less than 2, the bond is formed known as covalent bond. Okay? When the two same atoms share electrons in covalent bond, so the difference in electronegativity in this case equals 0. Okay? Like the difference in electronegativity between two chlorine atoms. Okay? Because both of them shared equally and there is a symmetrical distribution of electrons between them, okay? And when the two sharing atoms are not similar, the more electronegativity element attract the shared electron more strongly, and it formed unsymmetrical distribution of electrons between the bonded atoms, okay? This is diagram illustrate to us the difference between ionic bond, polar covalent bond, and non-polar covalent bond, okay? In ionic bond, complete transfer of one or more valence electron, okay? So sodium carry positive charge and chlorine carry negative charge. And the type of the bond is ionic because the difference in electronegativity between them greater than 2. while in two chlorine atom, symmetrical distribution of electron occurred. So the bond that formed known as non-polar covalent bond. In case of hydrogen and chlorine more electron negativity than hydrogen, so it attracts the electron of the bond toward itself, leads to formation of partial negative charge in chlorine atom and partial positive charge on hydrogen, and form a polar covalent bond. Okay, thank you, grade 11. Bye.